I'm going to talk today about database instrumentation, and I'm going to attempt to sell the idea of why developers should put effort into instrumentation and what use is it to you. And the challenge is, the rest of my day job involves performance optimization for people, and I write about it. I've written books about it. I spend a lot of my time with PeopleSoft, which is an ERP system. Some of the examples I'm going to show you today are drawn from PeopleSoft, and they're quite generic. PeopleSoft's a good example because it's a partially instrumented application, and it talks about the challenges of when you have instrumentation and when you don't have instrumentation. And I'm going to start off by trying to explain what I mean by instrumentation. The big challenge is it has to be implemented by developers, but it's mostly used by administrators in runtime for the support of production systems. It has some benefit in pre-production, but it's really aimed at maintaining production systems and delivering performance and reducing cost of ownership. But of course, we're asking developers to implement the code that needs to be put in place for this. And the thing about instrumentation is it identifies where you are. It tells you which program you're in, which procedure or function that's running, and that informs the performance metrics. And performance metrics are all about time. And the question in performance tuning is, how long did I spend doing what? And we spend a lot of our time profiling performance metrics to see where we spent the most time. And then wherever you spend the most time, you focus on that, saying, well, how do I stop spending time on it? If you're inside a piece of SQL, it might be, if you're not using an index and you're doing a full scan, perhaps you should be using an index. Or if you're spending a long time using an index, perhaps you shouldn't be using that index and you should be doing a full scan. It is as ridiculous as that. In the cloud, of course, the thing you pay for is CPU. So if you can find ways to reduce the amount of time you spend on CPU, you can improve performance and reduce resource consumption, and therefore reduce your cloud footprint and reduce cloud subscription and reduce cost of ownership. And that is what is interesting to the people who pay for the system, the customers. So the instrumentation tells you where you are in your application. So now you know where in your application you are spending your time. And so when I find the instrumentation points to a particular part of the application, I can focus on that and say, well, this is what I need to look at to try and take time out of the system. Now, Oracle tracks sessions in any way. It tracks the user, the service. You get information about the program, the operating system user, where the client process is running, the client machine. If you start a transaction in SQL because you've updated something, you get information about that transaction and you can see all of the SQL that's a part of that transaction. And if you're in a JDBC process, you can see an execution context ID usually. So you can track how that session moves through an application server. What I'm going to propose is that additional instrumentation is implemented, and Oracle have provided this package called DBMS Application Info. It's been there for a very long time. You can find it in the documentation as early as version 7.3.3 of the database. And you set two attributes on a session, mostly module and action. There's another one called client info, but it's module and action that are interesting because they turn up in the various things that track performance. Most importantly, they turn up in the active session history in the database. I want to distinguish between what is instrumentation and logging, debug code, trace. So instrumentation is written on the database session, whereas logging records that something happened in the code, that you went through a particular point in the code. And so you went through that point and you executed the debug code or you executed the logging code, and you get some information about that. You get some context. But the instrumentation is then picked up by intrinsic database processing. So on Enterprise Edition of Oracle, it gets picked up by the automatic workload repository. And it goes from the session to the SQL statistics in the SQL area, and then to the automatic workload repository as well. It turns up in the active session history. So in Enterprise Edition, Oracle will track each session every second if it's active and log that in a buffer. And then we can query that. And that function is called active session history. So having that instrumentation gives context to the metrics that we're collecting. You can also have session trace, which is a database function, a bit like having debug code in your PL SQL, and you get information about every SQL statement in a session once you've turned it on. You can see the execution plan of that statement, the duration of every executed fetch operation, and detail of every wait event, where the database spent time using a particular resource. If you've set module in action, you also get to see module in action in the trace when the trace starts and every time you change the value of module in action. So that helps to make your trace files far more useful. It helps you find the code in the application because it's been given context by module in action. Now, when it comes to debug code and trace, one of the concerns is measurement intrusion. By turning on trace and debug, do we impact the performance of the application? And sometimes you can. So the often asked question is, what about the overhead of setting module in action? Well, the overhead is absolutely minimal because you're not writing anything physically to a file. You're just setting something in memory or setting a couple of registers in memory. And I've seen people argue that actually the cost of setting it is negative, because if you don't set it, you will hamper your efforts to improve performance. So the overhead of the instrumentation is very low. So how do you set module action? Module action are registers held in memory in the shared global area in the database. They're exposed as a sys-owned object, and then if you're not logged in as a DBA user, you can see them through a $V session. And they're just a couple of memory registers that live on the session in the database. And today they are now 64 character strings. And that's all they are. And whatever is set in those two strings, it can turn up. You'll see it in $SQL area. As I've said, it will turn up in AWR and ASH. It turns up in some other places. If we use SQL baselines and SQL tuning, we can see the module in action there. You can enable trace on the combination of service module and optionally action, rather like a watch point in a debugger. Just as you can pause execution when you hit a watch point in a debugger, you can set a trace point, and it will say, when I see a matching module in action, I will enable trace, and you can set this up declaratively. And when it sets module in action to a watched value, it will enable trace, and when you set it to a different value which isn't watched, it will disable that trace. So you don't have to execute the code to enable trace on a session yourself. The module in action is recorded in the trace file, and some trace profilers will report that module in action. So utilities like Aura SRP does, but Oracle's TKProf does not. A utility provided by Oracle is TRC Sesh. It was originally there for merging trace files that came from different parallel query servers. But one of the things it will do is it will filter by module in action. So if I've got a big trace, I can say, just give me the bit of the trace for this module in action, and then I'll profile it. So that's an option too. How might I do that? Very simple demo. I'm going to watch the code for when it sets my module and my action. And now I'm going to write a little anonymous PL SQL block, and the first thing I'm going to do is I'm going to set my module and my action. By doing that, by calling DBMS application info and setting that modular action, I also enable trace just in my session because I've set modular action in my session. And then the code that I execute is traced until such time as I set it to another value. And at the end of my code, I turn it off by setting it back to the original values. What do I get in my trace file? At the top of my trace file, I get information about my session ID, the client, the timings, and there you are, there's my module and my action. And now everything below this was for this module and action. By the way, at the top you can see the trace file name, and you saw I set my trace demo as a trace file identifier. So that trace identifier is turned up in the trace file. You can make it a little easier to find your trace file in a directory of lots of trace files. So I can take this trace file, I can look at it directly, or you can run it through a profiler like tkprof, and you'll get information about every SQL statement, how long it took and what event it waited on. And that's the start of a performance tuning on that session. The other reason for setting modular action, and in fact probably the most useful one, is linking it to the resource manager. So the resource manager tells the database how to prioritize processes. If you run out of CPU on your database server, you want the high priority processes to make progress and let the lower priority processes wait. And you can define that through metadata, and there's an API that Oracle provide. It links to instrumentation in that you define rules that map certain modules and actions to certain consumer groups, and then the consumer groups have priorities attached to them. And there's various things you can map on. You can map on the username, the program name, but you can map on module and action as well. Now, whereas the watch point for trace only worked on equalities, so it had to be module equals this and action equals that, with the resource manager we can pattern match. We can use module like, and we can do a regular expression pattern match as well. If you've got variable values turning up in your module and action, and sometimes you do because you want to track what's going on within an application that way, you can pattern match the fixed parts of that text and ignore the values coming in from a variable. So here's an example of a resource plan that was designed for PeopleSoft Financials ERP. And we created this hierarchy of consumer groups. And essentially, at the very top, you've got Oracle background system activity. Then you've got online activities at the top. Then you've got high priority batches, lower priority batches. Online query and ad hoc query processes. And then further down, you've got low priority stuff, which is reserved for SQL Plus and background stuff like that. And then you've got other stuff at the bottom. And this is a hierarchy you define. You can define whatever you want really, but this is what we chose to define. The high priority stuff will take precedence over the lower priority stuff when the system runs out of CPU. And when there is CPU shortage, the higher priority processes are guaranteed certain percentages of CPU. You can also constrict the parallel query, degree of parallel query, and you can terminate things after fixed amounts of time if they've run for too long. Yeah. How do you do this? Here's an example of the mappings. So we've mapped the application servers that drive online to the online consumer group. And you can see that's done with a pattern match, PS app serve %, like Nike in SQL. Particular parts of the application that run the online queries, we've mapped that to the online query group. The batch processes, we've used a pattern match there because there's a number in that string which gives us the ID of the scheduled process. And then specific parts of the application, if it's a specific combination of module and action matches that pattern, that gets a higher priority group. What's going on there is that one is allowed to use parallel query, so it goes into a different consumer group. So we've designed this resource manager plan, and it reflects the business's definition of what is important. So it's not a technical thing, it's a business thing first, and then you reflect that in a technical design. How would I do instrumentation in PL SQL? This is my personal preference. I tend to use this set a constant equal to the name of the package. There's a nice meta variable that PL SQL provides. And I save the current settings for module and action. And then I set my module and action to my package name and procedure within the package. And now I've told my session I am now in the procedure and package. As I go through the package, through the procedure at different points, I might set other values. I might not, it depends on what the code is. At the end, set it back to the value you saved off at the beginning. And similarly, every exception and exit point do the same. So effectively, you've created a stack of modules and actions as you go through your code and you come back out. This is then reflected in $session. It's then recorded to Ash. It shows up as I go through in my performance metrics. I can now profile where the time is spent and work out which procedures and packages I should focus on to improve performance. Sometimes you need to be creative because you can't get your hands on the code. In some places, I've had to create triggers. Here in PeopleSoft, first time when a process starts, the first thing it does is it says, update my status to say I'm processing. So I put a trigger on that to say, set the module in action when a process starts to process. Sometimes you have to be devious. In one place, I've used fine-grained audit. I define an audit policy which catches a query on a control table, which is used to pass a parameter into a process. And then I can write a handler, a piece of PL SQL in a function, to set just the action as it goes through a process. So what's going on here is I'm using fine-grained audit to detect different parts of a reporting process, but it's inside a utility where I can't get my hands on the code. So I've had to find another way in to hang the instrumentation on it. And now I can see which general ledger report is running within a report book and say, well, that particular report within the wider report book is the one that's problematic. It depends. You wouldn't do this unless you had to. It depends on the problem you're facing. If you don't instrument an application, the problem is when you come to profile it, you don't get any data. But we ran an analysis of performance, and 98% of it's in JDBC Thin Client, and that's all you get to know about it, because the application is not otherwise instrumented. And you can't dig further. You can't say, well, this bit of the application is what's important. Compare that with what happens when you do have an instrumented application. You now have a breakdown of where the time is spent. And this is the kind of view you want to see, so that when you profile the time, you can see which is the most important. This comes off an HR system, and this component here at the top, that was maintaining an employee name in the HR system. So that's a frequently used function, so that's turning up at the top of the profile. Do we have to go and do some performance tuning on it? That's a slightly different question, but maybe, and if we did, that's a place where we're spending a lot of time. If you're going to do instrumentation, what would I say? When it comes to module and action, think of module as the parent of action. So to that limit, there is a hierarchy. But what you put into that 64-character string, that's really up to you. You have to decide what is sensible, what makes sense to put in there. All I'd say is be consistent with what you do across the application. Because when it comes to profiling the data later, that consistency will help. It is okay to put variable values into modular and action. It can improve the understanding of what the instrumentation relates to. You might want to identify a specific instance of a process. It might be a particular ID of a process. You might have several steps, and or several concurrent processes, and you want to identify which instance of the process it is. You may then need to strip these numbers out when it comes to profiling them later. That's fine if you're using the consumer group. It can be a little bit problematic if you're going to do SQL trace, because if you can't predict in advance what the values are, you can't use the watch points. They only do exact match. But you only use trace occasionally when you can't use active session history these days. Sometimes you've got to simplify what's recorded. So here I've got 3 entries for PS AppServe at R4, A6, 7 and 8. That's because they're on different physical machines. So you might want to strip this stuff out and when you calculate the profiles. And this is where regular expression replace becomes your friend. So you might want to strip from the dot or the at onwards. If it's on Windows, the app servers on Windows, we get this .exe, and if it's on Unix, we get at machine name. So I want to strip them both off and just have PS AppServe. Or it might be that there are numbers in that module in action, so I want to strip the numbers out. If it's a database job, I just want DBMS job and replace the job number with an indicator that says there used to be a number here. And sometimes you just want to pull those particular numbers out because you want to join them to tables in the application which tell you something. So if I have a process instance number in PeopleSoft, I look the process instance number up on a particular table and it tells me, oh, it's that kind of process. And it tells me who ran it and what parameters they ran it with. So it depends on the application what you do. There are no hard rules here. Sometimes you want to profile the time, and this is the kind of query I do a lot. So you say, how much time did I spend in each module and action on active session history, and I'm going to profile it by descending order of time. First problem here is I've got a blank module because shadow processes are not sometimes instrumented. So I'm going to replace blank module with a program name. So I'm going to introduce a null value into my SQL. And then the next thing is I'm going to strip out this exe, and that number off. Those 2 lines are actually 2 instances of the same process. They're actually on the same step because the step name is the action, so it tells me where in the program I am. But actually, because they're actually the same code, I'm going to lump them together. So I'm going to strip those numbers out after GLJP. And I can do that with this case statement and the regular expression substrings. And then I've got backup processes which have got some numbers in. Let's strip the numbers out of them. So I'll just make the case statement a little more complicated. And now all those numbers disappear. And I can see what the total amount of time spent on backup was up here. And those 2 GLJP lines have become 1. So I can see where my time is being spent. And this is hugely useful when you have an enterprise edition database with Ash. You can see an instrumentation on your application. You can see where your time went and what kind of activity was the database doing. This is just the first part of it, of the analysis. Why does any of this matter? Why should you spend time doing this instrumentation, analyzing this data? Well, in the cloud, performance is instrumented as cost. So what you pay for in the cloud is CPU. If you can reduce your CPU consumption, you can save money and simultaneously deliver better performance to the users. Because in the cloud, in particular in the cloud, it's actually true on premises as well, but particularly in the cloud, either there are times when you have no CPU free at all, in which case you should be using the resource manager to prioritize what is important to the business, the customers, or you're spending too much money on too much CPU in the cloud. Here is a real performance profile from a production system running PeopleSoft financials, and they have a typical heavy overnight batch. At the point in time when this shot was taken, they were running two 6.0 CPU nodes, so they had 24 vCPUs in total. And they're paying for 24 vCPUs. They're paying that $1,000 per CPU per month to Oracle for OCI. They're using the colored areas, but they're paying for the white areas and they're not using them. So they're not getting return on investment for the white areas. The blue areas are high priority, so the resource manager prioritizes that over the lower priority processes. And in fact, those lower priority processes were deferred until troughs in the high priority utilization occurred and enabled them to progress. So over time, we've been able to reduce the CPU availability. So we've squeezed the top of these spikes. Now the obvious result is that the runtime of the process extends. And they went down for a while to 4.0 CPUs instead of 6, until another system was made co-resident. And you allow this squeeze to occur so long as you are still meeting the definition of acceptable performance. And one of the most useful things this particular user did was say, these reports have to deliver by 2 a.m. because 2 a.m. on US East Coast is 8 a.m. in continental Europe, and that's pretty much when continental Europe goes to work. So long as the reports deliver by 8 a.m., we're okay. And in fact, you can see this batch finished at about 11:30, and today it still finishes at about 1 a.m. on fewer CPUs. So this approach of using instrumentation to drive the resource manager has enabled them to reduce CPU cost while still delivering their business requirements. And that's the combination of instrumentation and the resource manager. And that, I would suggest, is the justification for doing this. So instrumentation tells you when and where you are spending money, and the resource manager controls how you spend it. And that's why you instrument an application.